Hello, and welcome to When the Nearest Neighbor Becomes the Nearest Adversary. A fun little webcast that Mr. James Lee-Vidal and Larry Pesce have put together. So, how about we get right to it? We don't want to keep looking at this title slide for very long. So, who's joining us today? James, you're up.
Hey, everybody. My name's James Leyte-Vidal. I am the co-author of the SANS wireless penetration testing course and the IoT penetration testing course 617 and 556. I'm also a principal instructor with the SANS Institute, and I been doing the information security thing for about 20 some odd years now. Um, IT before that, and all other kinds of assorted things before that. Over to you, Larry.
Awesome. Thanks, James. Yeah, so I'm Larry Pesci, and with James, we both author the wireless and the IoT courses, specifically SEC 617 for wireless and SEC 556 for the IoT portion. I am also a principal instructor with SANS, and I think in many cases. Yeah, SANS loves to have instructors that are also practitioners too. And as part of my day job, I'm the vice president of services at Finite State, where we help deliver services of all sorts of stuff around IoT and wireless technologies and so forth. So, yeah. So this is the same sort of things that I've been doing for many years as a penetration tester, and some of the things that to continue to sort of do into my day job with some supply chain security as well. All right, so let's take a look at what we're going to cover today. Um, uh, to start off, we talk about the nearest neighbor as the nearest adversary, sort of at the startup of this webcast. But first, we want to make sure you all know what the nearest neighbor attack actually is and how it's worked and what was discovered and so forth. And there's been some very interesting things that came out of the discovery of what has been dubbed the nearest neighbor attack, specifically sort of indicating that it was potentially nation state related. And is it the A's, the P's, and the T's of the nearest neighbor attack? Specifically, is it advanced? Is it persistent? And what's the threat? More importantly, how easy is it for someone to come up with a similar type of attack? Okay. And well, James and I are going to go through the technical details, how this attack could have occurred, and some of the ways that it happened. But thinking about your enterprise, what are the defenses that we need to consider for some of those things, and then we'll sort of just do a quick wrap up as well. If there is time left for questions, we'll leave some for there. But if you do have questions as we are going through the presentation, uh, don't hesitate to put those in the specifically in the Q&A window. um, we are more than happy to try to address those in line. It makes this a little bit more natural flow. Even if we do have to take a little bit of a step back into some of that conversation, please do ask them. It's likely that if you have that question in your mind, there are probably three or four other people that also have that question. So let's absolutely, keep this a dynamic conversation. All right. So, what is the nearest neighbor attack? Specifically, November 22nd, just last year. I mean, it seems weird to say that because like it's just barely this year. So, only a couple months ago, Volexity released this report in which they indicated a TTP that they now refer to as the nearest neighbor attack, in which some Russian APTs grew some large, or APT 28, if I remember correctly, leveraged some Wi Fi networks to gain access to some organizations that were in support of various Ukrainian activities. And there's not a lot of detail on top of this type of stuff. Um, But the report released by Sean Kessel, Stephen Adair, and Tom Lancaster sort of steps through all the things they discovered, and they build this as a very sort of novel, new, never before seen um, TTP around using wireless networks to compromise organizations. And yeah, well, I think James and I had some opinions on the matter. All right, so this new novel attack in which Russian threat actors used to compromise organizations that had arguably never been seen before and was quite difficult for them to hunt down. So, effectively, what this nearest neighbor attack looked like is that the Russian threat actors compromised this organization in support, the ultimately the victim that we'll refer to it here, um, through a Wi-Fi connection. Um, they used, but they did it from the Wi-Fi. They weren't anywhere nearby. They leveraged wireless networks in the victim organization in supporting Ukrainian activities from other wireless clients that were nearby. Effectively, they compromised computers at a neighbor organization, and then used those computers next door at the neighbor to perform wireless based attacks against the Ukrainian organization to infiltrate that network, to gain access to internal resources, and so forth. Right. And there's a good possibility that they just leveraged native or add-on tool or limited add-on tools to conduct those wireless attacks. And we're primarily going to focus on Windows here, Windows system being compromised at the neighbors, and then focusing their Wi-Fi direction to the victim. Right. So once they have the ability to get on the wireless network, then it becomes a whole additional thing. All right, James, how about you take this one?
Yeah, absolutely. So, one of the things that Larry and I kind of found amusing when this came out is, it was touted as being a very novel technique, and from an attack perspective, they're right. We haven't seen an enormous amount of use of this particular technique out in the wild by threat actors. However, it is something that both Larry and I have used in tests ourselves that we've performed. Penetration tests with approval. And it is something that we also talk about in our class in 617. We have a module where we discuss this in greater detail. We refer to it there as bridging the air gap. It's kind of a bit of a play on words there. Yes, I know when we're talking about air gap, that's a different concept in industrial environments and all that. But the idea here is if you can compromise a device, you can then leverage that device as a pivot point, right? Same as we do over normal wired networks, but leveraging the fact that most devices that you compromise at this point have some kind of Wi-Fi interface on or another type of wireless technology. But for this example, we're going to focus on Wi-Fi. So taking that Wi-Fi adapter, we might be able to utilize, ideally leveraging, living off the land premises and, leveraging stuff that we have on the device whenever possible. And then going ahead and kind of getting a scope of the land near that victim device. What are the other networks that are available? And see if we can go ahead and extend our access out using that Wi-Fi interface to access some of those other networks and capabilities. So it's pivoting, right? But it's over wireless. So we've seen this before. We've performed this before. The novelty here is the use by a threat actor and actually going from one organization to the other. And we'll get into a little bit more detail of why they had to do that in the next slides.
Yeah, yeah, James. I'll also here add a little bit here too that when we start potentially talking APT and any of those things, advanced and persistent. Um, we've been this slide is one that is straight out of 617 on day one. So this is one of those sort of concepts that we're teaching you very early on. Now, it doesn't necessarily have, all of the OSINT and that type of stuff that we're going to outline in the scenario for the nearest neighbor, but we give you all the skills to have been able to put this type of thing together as part of the class. So we're stitching a little bit of the stuff that we know about and that we teach you as part of this class to be able to make this happen. Um, and James, you mentioned, hey, we call it bridging the air gap as part of class, but I'm kind of proposing with James that maybe we change this because that was an absolutely a question that we got in one of the last times I taught. That one of the students says, "Hey, an air gap really means something different. This is probably, I get where you're going with the name on this, but maybe it's not the right fit because everybody else considers that a different name." Well, you know, now we have a name for it, right? We arguably have a name for it, and it's now the nearest neighbor attack. So, timely when that discussion happens about, hey, you should pick a different name, that now we've kind of got a different name for it. All right, let's move along.
Absolutely. So now there are some limitations to this approach, right? And as I'll mention in the upcoming slides as well, there were indicators that the threat actor in this particular scenario may have compromised multiple different organizations in attempting to gain access to their intended target. And one of the reasons that that might happen is this kind of approach is not without its limitations, right? It is very possible that someone can gain access to a machine and be immediately stymied just by the hardware configuration on the device. If you are working with a compromised client and trying to utilize it for these purposes, you're going to need to be connected to it via a wired interface, or at least have another wireless interface that is free on the device and not in use. And the reason for that is your capability to do scanning, analysis, and so forth over Wi-Fi is going to be greatly hampered if that is where your connectivity is going on as well. Switching out of manage mode, which connects you to an access point, and moving to monitor mode, which is kind of a more unfettered type of access to Wi-Fi, allows you to look at all of the radio waves around you on a specific channel, not just the ones intended for your network, but it disconnects you from whatever network you're connected to currently.
Yeah. Hey, you're getting ahead of yourself.
I know, I know, I know. I'm
It's
excited. I'm sorry.
exactly. I know. And I think with that too, there's some potential limitations here. And again, you could potentially use Windows or Mac OS. We've kind of gone with the approach here, specifically in this threat actor scenario, that it was likely Windows that were exploited here. But we'll talk about that when as just focusing on Windows as we move through. So um, uh, with that. Um, the threat actor groups um, had to do some kind of interesting things here. And James, why don't you take the first part of this one away?
Yeah, yeah. So this has been attributed to APT 28, which is a group out of Russia. The presumption here is that this organization and the folks within it were not able to travel to the United States to leverage, physical up close attacks. So, but they did have credentials. They had valid creds for the target organization. But when they attempted to access that organization via internet facing resources, they were stymied by multi factor authentication, which is great, right? And that's what we should be doing from a defensive perspective. So those controls worked. And that's where the opportunity came up here to do something a little bit novel and to try a different approach to access this organization that they couldn't physically get close to, but they also couldn't access it over the internet.
Yep, exactly. And that said, doing potentially another little bit of reconnaissance. are there wireless networks present in the organization that they're looking to gain access to? But that requires you to be in close proximity yet again. So, without being able to put boots on the ground near the organization for a very variety of reasons, how do we start verifying that there are potential Wi-Fi networks associated with this organization, nearby this organization, that we could start doing some manipulation to gain access, potentially to go around those restrictions with multi-factor authentication? And we do that by a whole bunch of open source intelligence. James, I'll let you take this one away, and I'll chime on the end on this one.
Yeah, absolutely. So in this particular case, if we want to, get kind of the scope of what organizations might be nearby that are good pivot points to kind of work through that might have good physical proximity. I mean, remember in this case, we're going to be most likely dealing with Wi-Fi. We're dealing with Wi-Fi adapters in an organization that is commodity equipment. We're not going to have specialized antennas or amplifiers or things like that that we can use to try and increase our range for connectivity. So we're going to need orgs that are really close to the target. How do I find those orgs? I mean, we've got resources like that readily available to us, whether it's Apple Maps, Google Maps, any of our kinds of mapping tools. We can go ahead and see organizations. And I'll tell you, in this particular case, this was not what happened here, but in a lot of organizations, you'll find them in large kind of metropolitan downtown areas, and maybe they'll occupy a couple of floors of a building. But they may have another organization, another company on the floor above them, and another organization on the floor below them. Great opportunistic targets there. So we can utilize a lot of these existing mapping tools to go ahead and get a feel for what other organizations are nearby. Now that
Yes.
gives us
Oh, go
organizational
ahead.
proximity. Go ahead.
Yeah, yeah. So exactly, if we know the address of our intended victim, that in the case of the nearest neighbor attack, the organization in support of Ukraine, if we know the address for their office space, we can just go to the map, find the names of businesses nearby, to something like Google Maps or Apple Maps, find names of businesses nearby, organizations that are within Wi-Fi range, and then take that same address and bring this over to something like James's display of Wiggle here and zoom into the map. Now, Wiggle has data from war drivers, point in time aggregation of wireless networks and their location on the planet that they have submitted for um, uh, you know contest points. And by contest points, it just means you're cool and you've done a lot of this. So by searching in the nearby area and even zooming into the map, it will show you the access points nearby to the victim organization, and even potentially that the victim has some stuff. You start looking at these wireless network names, and if we see so many times that the wireless networks match very similar to the company names, and they've got guest networks and you name it. So it's probably pretty attributable to networks nearby in various companies, which we can then leverage other open source intelligence gathering to figure out IP space and websites and users to send emails to compromise those neighbors, so that then we can have a presence nearby. All right.
So once we've identified organizations that are interesting to us, this is where a lot of the heavy lifting starts, right? We're going to need to go ahead and do reconnaissance on these pivot organizations, same as we would with a normal target. Exploits, same as we would with a normal target, because they're part of the chain, right? We're trying to get access to an environment to go ahead and pivot from that and work outwards. Now, this is not perfect. We're going to need to potentially access a whole bunch of different devices to find the ones that have that special combination of capabilities and hardware and even software that lets us go ahead and pivot out from that organization, do the reconnaissance that we want to do. maybe we can do some limited things on one device and move to another and kind of build that profile as well. Again, what we saw from Volexity indicated that multiple neighbor organizations were compromised. That is probably par for the course for this kind of thing. You're going to need a lot of different workstations to find kind of the right combination of factors that you need. You could have all the right hardware and not have sufficient range, right, to be able to cut to the end target organization and continue on what you're trying to do. So things do have to align uh, well for this kind of stuff to be effective, which may mean a lot of trial and error.
Yep.
This is
Yeah.
where the persistent comes in.
Yeah, exactly, exactly. And and James, you make some great points that maybe you've got the right the right hardware solution. You're connected via Ethernet as opposed to Wi-Fi, so you can use that Wi-Fi adapter, but you're not close enough. Maybe you're close enough and you've got a Wi-Fi adapter that you can use, but maybe you don't have enough privileges, and a whole host of other potentials there. So there's also a possibility that the threat actors had to do a lot of work to one get into the organization and explore all of those neighbor organizations to try to find that right device with the secret sauce, as James, as you put it. All right, so James, you already got there, so why the two interfaces?
Yes. So, um, at a very high level, uh, Wi-Fi adapters, whether they're in your laptop or your desktop or card you plug in, whatever it is, Wi-Fi adapters can run in one of a couple of different modes. The most common modes that you'll interact with are what we call managed mode, which means that your wireless adapter is acting as a client on a Wi-Fi network. So that adapter looks for advertisements from access points. They go ahead and negotiate capabilities, and then they go ahead and connect to that access point and send and receive data. That means that you're actively connected to a network and you're actively interacting with it. It limits the other things that you can do with that particular radio. And some of the things that an adversary may want to do in this scenario is go ahead and pull information that is not related to the wireless network that they're connected to, right? Because that's not their target at the end of the day. So collecting this other additional information can be done via another mode of your Wi-Fi adapter, which is called monitor mode. Monitor mode, by definition, means you're not connected to any network. You don't even theoretically send packets at all. It's designed to be a passive mode that just collects information from any radio that's transmitting on that channel that's within range of that device. But this means if that particular device that we compromise is connected via Wi Fi and we're connected to it via Wi Fi, we can't flip it out of managed mode and put it into monitor mode because we're going to get disconnected. If any of you here have done penetration testing and you've been connected to a device, maybe tweak a firewall rule or change something, and all of a sudden you see your connection drop and you get that sinking feeling because now you're not getting back into that box. And that's exactly what can happen in this kind of scenario. So ideally, we need devices with two network interfaces. That is typically going to end up being one wired interface and one Wi-Fi interface. So you do need the stars to align here for this kind of capability to work. So again, a lot of trial and error. Once again, this is where the persistence comes in. I think they definitely check off the P for this particular threat actor.
Yeah, yeah, James, and I was thinking back while you're talking about maybe a little bit to our last slide, excuse me, as well about having to do this a lot of trial by error. Like, I think about the average organization that most devices that you're bringing into the organization. If you're going into an office, that the end user's device are all laptops and they're Wi-Fi and they're typically Wi-Fi only. I mean, I don't think I ever went into an office and plugged stuff in via Ethernet cable in a long, long time. So maybe they're having to compromise a client device, a laptop, one of the user's laptops, so that they can then pivot to another device in the organization. Maybe they got a small server rack or something in, like a small office or something. And maybe they're not buying the same level of enterprise gear that larger organizations do. And well, that server that they've got in the back closet of the office is really just a converted desktop PC, and it's got a wireless adapter in it, but it's running Windows or something of the like. So yeah, there's lots of need to do trial and error and potentially pivot within those neighbors to get that right place, so you can grab that Wi-Fi adapter and bend it to your will. All right, so let's say as part of that threat actor, we find the neighbors. They've got close proximity Wi-Fi to our victim. We do a whole lot of hard work, and we end up on a Windows system. Um, and when James and I talk about this in class, we talk about a specific C2 framework, but any C2 framework that you could use for something like this as a penetration tester, as a threat actor, as long as you can get access to a command prompt here, um, we can start leveraging some of the built-in tools under Windows to start getting data about the networks around us. And step one, as we've really been indicating, and James has really hammered home here, is that in order for us to start interacting with the end victim's Wi-Fi network, we need a wireless adapter that is unused. And in this case, leveraging living off the LAN tools, such as NetSH with the WLAN verb, we can use NetSH and the WLAN verb to tell us about the wireless adapters in the system. And in this particular Windows system, there is a wireless interface. It's called the wireless network connection. And fortunately, it is in the disconnected state. And well, that's really good news in this case for the threat actor. After lots of trial and error, they finally have a system that is close enough that they've been able to compromise that you're likely connected via Ethernet, and that there is a disconnected Wi Fi adapter that we can bend to our will as that threat actor. All right, verify that we can see those networks. Are we close enough to the target? NetSH with the WLAN verb, living off the land of that compromised host at the neighbor. Uh, Use the NetSH WLAN show networks command. And the show networks command gives us the ability to see what other networks are present in the vicinity of this now compromised host. And hopefully, the network is visible and we have the ability to connect to it. So in this case, NetSH WLAN show networks, it's telling us it's four networks. We saved a couple just to make this slide a little bit more reasonable in its size. And there's a couple of networks here, and maybe one of these are a victim. I really hope not, because yeah, a web network and an ad hoc one. Yeah, you got to figure they probably did a little bit better. But now that we're here, we have a wireless adapter that we can use, and we're in range of a potential network after doing the scanning with our compromised device. We now really want monitor mode for our next target. James, I'll take this one and I'll let you do the next available here. Um,
Okay.
for doing monitor mode, there's two ways that we can do monitor mode, and this one's the old way. And for this particular instance, we're definitely talking the old way because we're dealing with those neighbors. And who knows what those neighbors are? Maybe these are just that small law firm that still has a bunch of, like like a Windows 7 system that just does a Samba share in the back closet, and who knows. But one of the older ways you could get monitor mode is through installing a tool from Microsoft. It's a Microsoft made tool. It has been deprecated, but it's still available on Microsoft's website last time I checked. You go and install Netmon on this victim device. Run the NM Wi-Fi utility. And it gives you the ability to switch to monitor mode with the GUI. Once you have the wireless adapter, the last one was named the wireless network connection. Same here. You switch to monitor mode and do the apply. You can use the Netmon capture tool from the command line to start capturing wireless packets seen in monitor mode, meaning all of the networks around and all of the base 802.11 Wi-Fi traffic into a packet capture for us to start investigating what types of traffics is happening on our end victim network from the neighbor. Now, the problem here is that one, Netmon has been deprecated, it's been end of life by Microsoft. I haven't tried it on a new version of Windows like Windows 11, but there may be cases when we encounter older stuff. Um, Also, Netmon spits out its packet captures in a Microsoft proprietary format, which is inconvenient because we have limited usability in Wireshark, and there are very few tools that can actually read those captures. So in 2015, Mr. Joshua Wright wrote a tool for us under Linux to convert those Netmon captures to the quote industry standard libpcap format in a standard framework, so that then we can use that output with all sorts of other tools. Better support under Wireshark, Aircrack NG, Hashcat, you name it. Oh, it does. So Tim is replying in chat here that it still works on the one of the latest Win 11 versions and 23H2. I don't know how new that is, but I'm assuming that Tim is noting that it's relatively new, which is kind of terrifying. So, again, not without some constraints potentially here. James, I'll let you take this one.
Yeah. So one of the reasons that we're kind of jumping through some hoops here is to do monitor mode capture in Windows, is because of some interesting design choices that date back to the 2000s. When Windows Vista came out, Microsoft wrote a new device interface specification for network adapters. And as part of that new specification, it required for native Windows drivers the ability to support switching a Wi-Fi adapter into monitor mode. What they did not do is provide a capability from a software perspective to do that. So if you've ever gone into, control panel, looked at one of your network adapters, or device manager, looked at one of your network adapters, and you've got all of those, options that you can tweak and so forth. There's no capability in any of that to switch an interface into monitor mode. Which is why we need these additional utilities. So, we still have Netmon kicking around. It is a bit older, and if you've never looked at the Netmon interface, I don't think it's changed much in the past 20 or so years. It looks like NetStumbler and Wireshark had a baby. It was, you've got like this, left panel with all the networks, and then you've got the right panel, which looks very, very Wireshark-esque. But we do have some newer options. So before those network interface specifications changed, monitor mode was very difficult to do in Windows. You could buy a particular USB dongle coupled with some software, and that was one of the biggest games in town to do monitor mode Windows. So we have the capabilities in hardware, we have capabilities in drivers, we just need software. And so Netmon is one of the ways that we can do that. A more modern option is a PCAP driver for Windows that is actually written by the Nmap team. So, the great folks at Nmap who still give us these, wonderful port scanning and, host discovery and identification tools like Nmap, they actually have another software utility called npcap. So npcap will allow you to do that monitor mode switching. If you install Wireshark on a Windows box, you can actually, if you're doing a GUI installation, it will prompt you to install npcap alongside it so that it can do monitor mode capture. Interestingly enough, you can install Wireshark silently from the command line and install a command line equivalent, which is Tshark, and it will skip over the NPCap installation. And the reason for that is NPCap is a free tool to use in its community format. But if you want some of the additional bells and whistles, like the ability to do command line installation and so forth, they have a professional version of that. So you can buy NPCap Pro, which allows you to do command line installation and silent installation and all that kind of good stuff. The problem with NPCap Pro is that you got to pay for it. And I'm all for supporting software developers in their work, but when it comes to you got to pay for it, it's call us for a quote levels of pricing. So the thing with NPCap is with NPCap in conjunction with a tool like Wireshark or Tshark, we can do monitor mode capture. It's getting it on the box. And so doing it from the GUI is fine if you have that access. But there are some other options. And that is if you can, scroll through GitHub, you can definitely find some PowerShell scripts out there that will work around this pro limitation and allow you to do NPCap Community Edition installations via PowerShell. So once you have those two components, you're off and running. You can go ahead and do monitor mode packet capture from a Windows device.
Yeah, James, and I'll chime in here. I think the trolling of GitHub to find those PowerShell options in this particular case, especially if we're starting to think a little bit more in the advanced side, it's, in my opinion, is really the way that you need to be doing that, because every other option requires that you have GUI access to install Netmon, to install Wireshark with NPCap, and you name it. And you've got to have GUI access, meaning you're going to be taking control of someone's screen, and that's one of the easiest ways to get caught when the mouse starts moving around and windows start popping up in front of a user. And again, this is another one of those cases where finding the right system with all of those features that doesn't have a user sitting behind it may also be very helpful. So lots of need to have that culmination of all those types of scenarios. All right. So, um, maybe this slide is a little misplaced, but in any case, we're gonna talk about it a little bit here. So, you know, we get some packet captures, and then we go as the threat actor, we go about getting some. All of the things that we need to do to join that victim wireless network, we now need to go connect to that network, and you can absolutely do that from the command line with NetSH. Um, but it's arguably not all that easy, because we have to leverage the concept of a stored profile, otherwise part of your wireless preferred network list, a network you've connected to in the past that has the Windows has stored that data on. And one of the ways that you could do that is to, as the threat actor, you've now got everything you need to know about that network, any credentials. You stand up a fake network near your computer. You connect to that network, get it stored in that profile with all the credentials that you might need for gaining access to the Wi-Fi network. Take that profile and export it, upload it to your wireless victim at the neighbor, and import that profile there. And then use NetSH to connect via that profile, and that profile will go out and connect to that network. And then you now have access to your end victim, to do some exploration. The other times here as well, yeah, sure, you can do that from the command line and upload and download and create all this infrastructure and so forth. If you've already got GUI access to go do some of that other stuff, like Wireshark with NPCap and so forth, why don't you just go configure the wireless adapter via the GUI, the Microsoft built-in GUI. So there's always that way as well. All right. So uh, we talked about doing that packet capture and going through all of those motions to get packet capture. But why? Why does the threat actor need to do the packet capture in this particular case in monitor mode? Well, it is very likely that we need to go. We've tried to go through the front door. We've got credentials to try to get on the VPN, but we're stymied by the two-factor authentication. So we're going Wi-Fi. But the victim organization has some protection on their Wi-Fi networks. And as part of that, if they've got some protection on those Wi-Fi networks, we need to capture packets in monitor mode for our victim network and the devices interacting with that network, so that we can use that for recovering credentials. Some other things that are also kind of neat here when we think back to some of our earlier discovery, um, if we can observe our victim networks on something like Wiggle, Wiggle is also likely going to have the type of network security in use as part of that. It may not be perfectly accurate, but it may be spot on. So we kind of know what we're getting into right away when we're trying to capture this data and why we're capturing this data, because the victim network has some Wi-Fi security, and many of those types of security are being able to be broken if we have enough or the right type of data in our packet captures. Specifically, for us to do a lot of offline password cracking for either something like WEP, oh gosh, WPA2 pre-shared key, or even WPA3 pre-shared key in transition mode, effectively making it backwards compatible to WPA2 pre-shared key and subject to all the same type of attacks. Okay. So now we've got some packets. We'll go and do some packets. But if we were to start doing some of this, credential recovery for any of those offline methods, um, those offline methods you can take some pretty significant resources to either complete, or will be hogging all of the resources of that end system. So you don't want to be doing that at the neighbor's systems, because that's another one of those ways that they potentially get caught. Because the next thing you know, somebody in the organization is complaining that their desktop computer is so slow, or so slow accessing the file shares or printing, because all of the computing resources is being chewed up by the threat actor, trying to crack passwords. Right? So capturing those packets and then the threat actor bringing them back to their resources gives them the ability to start leveraging one or multiple GPUs with Hashcat and even some AWS infrastructure here, to throw all sorts of horsepower and not be noticed by that neighbor victim. Uh, in some cases, using something like Hashcat, you might need to take the contents of the PCAP with that data. You need to crack those wireless network credentials in some trivial conversion and let it run. Now, not all of the security types we might encounter here are subject to offline attacks, such as capturing packets and then just throwing a bunch of horsepower at them to recover credentials for those networks. In some cases, we might need to do active online attacks. Instead of just going into monitor mode and listening and capture packets and hit those offline, we might actually need to start slinging packets from the neighbor to the victim. And some of those would be stuff like Wi-Fi protected setup, which typically is only found in consumer grade gear, and not in more enterprise stuff. But we all know how that goes. You've got some enterprise gear in your corporate environment, and it's there for a temporary problem, and it becomes permanent. Okay. Another one would be WPA3 pre-shared key, not in transition mode. That WPA3 and its additions effectively breaks the ability to do offline password guessing attacks, but it's still subject to online attacks. Okay. And on the Wi-Fi protected setup, or the WPS, we can use tools like Reaver and WPS Pixie Dust to recover credentials potentially. Uh, but some time-consuming tools for WPA3 shared key because it is sending passwords one at a time to try to authenticate to the network, is a tool called Whacker. Now, some other challenges here. Reaver, WPS Pixie Dust, and Whacker are all Linux-based tools. And we've focused our attacks here on those Windows endpoints at the neighbors. So this is yet another challenge, and some of the possible options here that these threat actors could have used would how do you run Linux tools on a Windows system? Well, maybe they could have deployed some sort of small type of virtualization. Yeah, Windows subsystem for Linux, exactly. WSL right here on the slide. Now, I specifically haven't tried Reaver, WPS, Pixie Dust, or Whacker on WSL, but I'd like to think that that is probably a reasonable option. So there's always ways. Now, it might be a little bit harder to live off the land in this case, but if we're this far in, you're probably not likely to not as likely to get caught.
One other thing I will add to that is if you can shop around a little bit and you have the flexibility to do so, and you can find, for example, if a company, if that organization has folks that are in like the software dev business or even like design, they tend to have a lot less restrictions on their workstations. Devs, especially, will not only typically have elevated rights to their box, but they will also typically have WSL installed. Sometimes they'll have Docker installed. And it adds a lot of flexibility at that point.
Yep, yep, exactly, exactly. All right. In some of the cases, you can't do online password guessing, offline password cracking. Sometimes, in a really good organization, I'll argue that the security types in actually need to manipulate a client, or they need to stand up a fake access point in an attempt to lure one of the end victim network's clients to this fake network to perform actual interaction with the client. And these would be things like WPA2 Enterprise and potentially WPA3 Enterprise. It's kind of a little bit of an unknown on the WPA3 Enterprise size, but still very likely. And there's some other things around WPA3 Enterprise that are potentially tricky too. Okay. But in these cases, again, in order to interact with the clients to convince the client to connect to a rogue network to cough up credentials, in this case, the rogue network being at the neighbor controlled by the threat actor, you need to get a poorly configured client to connect to a network. Okay. And you're typically using something like a custom host APD version, something like host APD-WPE, with a configuration that instead of actually doing the authentication, it looks just like the end victim's network. The client device at the end victim network connects to the network and then provides some sort of credential type of information, but to a rogue network, one controlled by the threat actor over at the neighbor. And again, these are tools that are under Linux with host APD-WPE. So we're running into some of those same problems here where we may need some virtualization, some Docker, or even WSL. All right. So we do some packet capture. We get some online attacks to recover passwords. We do client interaction, and however that's going to affect that end victim organization, and we get credentials. Great. Now we get credentials for that Wi-Fi network. Maybe it's WPA2 pre-shared key. Maybe it's a username password pair for something like WPA2 Enterprise. We now can configure that system to connect there. We kind of covered that a little bit earlier. Take the compromised system at the neighbor and make it connect to the victim network with the credentials that we recovered. Now we're in the victim network. we're on the network. We're behind the nice we're on the nice soft chewy center. We're behind that hard crunchy exterior, behind that VPN and so forth that required multi-factor authentication that we didn't have. So it's going around the back door where the key is a lot easier to interact with, arguably. But we had to go ways to get there. So now all we need to do is start, um, you know, doing some of those things on the Wi-Fi side. James, do you want me to take this one, or do you want to hit it?
I can go ahead and talk through this one.
Great.
So when it comes to this kind of stuff, of course, when we talk about attack techniques, even though the courses and most of our perspective of Larry and I is largely offensive, it's always worth talking about the defensive elements, right? Because no no test is complete without telling people how they can fix stuff. So we do need to think about what are some of the things that we can bring to bear to defend against some of these kinds of techniques. Um, some generalized recommendations that we can make for you when it comes to Wi-Fi. Of course, moving to our best network offerings whenever possible, and by that, from a network security perspective, we're talking about um, what we're talking about really depends on what your clients can support. Um, or if you're an environment that is still rolling with boxes that are 5 6 years old, it is very possible that WPA2 Enterprise may be the most robust security for a Wi-Fi network that you can use. There are newer options. We have WPA3 on the table now. WPA3 has been kicking around for about 4 years, but has not seen a lot of enterprise adoption. WPA3 in enterprise mode is not a bad option. It is an improvement generally over WPA2, although it is not without its own problems. One big piece of advice, though, is if you're going to deploy a WPA3 network, deploy it as a pure play WPA3 network. Do not deploy it in compatibility mode. Yes, it stinks sometimes in an organization, especially a larger one, to support multiple SSIDs, but that is the right way to do this. Deploy a WPA3 network that only supports WPA3 clients so that you can use the most effective security controls possible. And then gradually migrate people off your WPA2 networks. And once they're done, make sure you decommission those WPA2 networks. WPA3 transition mode networks are, not an enormous improvement over WPA2 networks because they bring all of the WPA2 flaws along with them because they have to support that backwards compatibility. Also, when it comes to detection mechanisms, how do we detect somebody standing up a access point with the same SSID as our SSID, all that kind of good stuff? Um, Rogue AP detection programs are something that you should be investing in once your organization gets to a certain reasonable size. Sometimes those capabilities can be built into your Wi-Fi deployments, depending on what kind of manufacturer you're using. You can also take this and deploy things like mobile forces, right? Take your interns, take maybe a SOC analyst 1 day a week, that kind of thing. Have them walk around in your environment, measure, look for networks and see what's there, compare it against your known asset inventory, and then run down the things that don't match. You do have a known asset inventory, right? Right. And by the way, this is where I point out I've worked at Fortune 100s. Everybody thinks that the security things that you're terrible at, that your organization is the only one that does them. No, no, everybody does them. It happens, right? But it doesn't mean we can't strive for better. Also, wireless IDS. So wireless IDS is not the same beast as wired IDS. One of the biggest differences is the deployment of the sensor network. You need either dedicated sensors or at least dedicated radios within a device like an access point to be able to do these detections. Also, wireless IDSs tend to be costly. One shout out I do want to give here, it's still an alpha quality or it's still an alpha release, but there is an open source project right now called Enzyme, Nzyme. And it is an open source wireless and wired IDS. It's got a lot of features. You can run sensors on small, single board computers like Raspberry Pis and things of that nature. It's a really good piece of kit, and it's only going to get better. And you can have it for the low cost of basically your sensor hardware and your time. So
Yep.
definitely
It's
take a look at that. Go ahead.
yeah. Enzyme is free 99, as in
Yep.
free, FREE 99. And I hear so I was at ShmooCon last weekend, and I heard that Leonard Koopman, the author of Enzyme, was there, but I unfortunately didn't run into him. But some other folks did, and I hear he's working on some sensors for very low powered devices, such as some very small devices that are using the the ESP32 type of chipset. So super inexpensive, like making sensors to do wireless intrusion detection on devices that only cost a couple of dollars.
Absolutely. Yeah. So keep an eye out for that. That should be coming fairly soon as well. Also, logging, right? Don't forget your logs, just like we do with normal authentication. Same thing with Wi-Fi authentication. Look for those login failures. Look for accounts that are engaging in unusual activity, logging in from unusual sources, unusual locations.
Yep.
Make sure those
What?
logs are getting reviewed and ingested.
Yeah.
Go ahead.
Why is James logging into the Wi-Fi network at 2 o'clock in the morning? The office is
Yep,
closed. Right.
exactly. And then don't forget when it comes to your Wi-Fi as well, don't forget that segmentation, right? Wi-Fi should be in some and most environments treated as an untrusted network because you don't run network jacks out to your parking lot, do you? If you did, you probably wouldn't consider them trusted, would you? And yet, in most environments, you're going to be able to connect to your Wi-Fi network from outside of your physical location. Remember the high-rise office building I talked about, the people above you, the people below you. There are plenty of ways for people to access a Wi-Fi network without being in your physical proximity. So treat that segment as untrusted. Make sure there's good segmentation controls behind that.
Yep. And this comes exactly out of some recommendations that when I did a pen test on a really robust network here, is that we were able to get into the Wi-Fi network because it had to support legacy gear, so the security was rather weak. But we got on the network, on the Wi-Fi network, and there was nowhere for us to go. You know, and there was no other traffic for us to observe after we could decrypt it, because the effectively the output of the Wi-Fi network was plugged into the forward-facing portion of a VPN. And if you wanted to gain access to internal resources from the Wi-Fi, you had to fire up your VPN client, connect to the VPN that was in front of the Wi-Fi network, and authenticate there. Then all of the traffic going over the Wi-Fi network was protected with the VPN, and that VPN had the ability to support multi-factor authentication on it. So now you're back to the problem that these threat actors had, why they went after the Wi-Fi network. That great, you got the Wi-Fi network, but now you still need MFA, which they didn't have. So some really robust options here, and of course, don't run that on an open wireless network or web. Do something, do the best you can on um, the Wi-Fi security side as well. All right, so I think that about wraps us up. We do have a moment or here for questions if you have them. I know a couple of them came in, and we tried to poke at those in the Q&A window. So um, to reiterate, stalling for time here, folks have got some questions. This presentation will be available to you at the registration links. Um, so uh, that presentation will always be available to you, and we'd love to see you in Sec 617 or in Sec 556 to come talk wireless or IoT, and we'll see you in one of those classes, hopefully. If not, be careful about your neighbors. Excellent, James. Any final thoughts?
Um, I don't think so. That's about it, man. Look, right on time.
That's because we're professionals.
Yeah.
Yeah.
Thank you, everybody, for your time and attention today. We really appreciate it. And you'll be able to access the recording probably within about 24 hours at the webcast link. Thank you so much.
All right. Thank you very much.